Okay, the next topic which I'm going to discuss here is there are three cases in which force is applied. Let us consider this is a mass of a ball of 5 kgs. The ball is having 5 kgs. A boy has kicked a ball now. So a ball is having an initial velocity 2 meters per second, its final velocity is 4 meters per second. The rise in the velocity in a ball is just because of a boy has applied certain force on the ball now. Ball has moved from here to here. So what are the things given here now? Initial velocity is there, final velocity is there, time is there. But what is not there, if you observe, displacement is not there here. Okay, in this situation, there is no discussion of displacement. If you observe the second case, a person has applied force on a ball, its initial velocity was 0. Its initial velocity was 0. Because of application of the force, after 2 seconds, the ball has traveled a distance 8 meters in 2 seconds. This is the second situation. What is not discussed here, there is no discussion of final velocity, if you observe this situation. Now, in this third situation, if you observe, a boy has applied certain force on a ball, because of which the ball has moved from this end to that end. Its initial velocity was 2 meters per second, its final velocity is 4, and it has traveled a distance of 4 meters. What is not discussed in this case, there is no discussion of time here. Okay, so we have only three formulas which are very important in kinematics. What are the three formulas? Let us discuss one by one. So one is V is equal to U plus AT, another is S is equal to UT plus half AT square, the next one is V square minus U square is equal to 2AS. So which formula to select when, that is very important here. If you observe three kinematic equations which are very important, the first equation, there is no discussion of displacement. The second equation, if you observe, there is no discussion of final velocity. The third equation, if you observe, there is no discussion of time here. Okay, it's very easy to understand now. So here, in this case, there is no discussion of displacement. The first formula suits here. So we can write V is equal to U plus AT. Understand? So you can write A is equal to V minus U by T from this formula. Next, you can write F is equal to M into A. Therefore, you can write F is equal to M, that is 5 into A. A means V minus U by T. So V minus U by T is 4 minus 2 by 2. That is F is equal to 5 into 2 by 2, which is equal to 5 newtons. The first situation, the answer, the boy has applied a force of 5 newtons. The second situation you observed, initial velocity is 0, force is applied. It travels a distance of 8 meters in 2 seconds. So in this case, what is not discussed, final velocity is not discussed in this situation here. So you have to select a formula in which there is no final velocity. Then you can write this as ut plus half at square. U is 0. So you can write A is equal to 2s by t square. And F is equal to M into A. Therefore, F can be written as M into 2s by t square. Therefore, this is mass. Mass is 5 kg for a ball. So 5 into 2 into 8 by 2 square. That is nothing but 4. So 4 ones, 4 twos 8. So 2 twos 4. 4 fives 20. That means in this case, the boy has applied a force of 20 newtons. Then let us see the third situation in which initial velocity of a body, there is a ball is 2 meters per second. He has applied a force. Understand? And a ball has reached up to here 4 meters per second. It has increased its velocity and traveled a displacement of 4 meters. Then in this case, there is no discussion of time. Select the formula in which there is no discussion of time. Then you will be writing V square minus U square is equal to 2AS. A is equal to V square minus U square by 2 into S. And you know F is equal to M into A. Therefore, you can write 5 into, because a ball is having a mass of 5 kg, 5 into A. So what is A here? V square minus U square. V is 4 square minus 2 square by 2 into S. S is 4 here. So F is equal to 5 into 16 minus 4 by 8. So this can be written as 5 into 12 by 8, 4 twos, 4 threes. So 15 by 2, that is 7.5 newtons. So in this case the force applied is 7.5 newtons. So three different situations gives you three different formulas here. Okay, so the formula, what is the formula for the first case? If you observe, the formula for the first case is F, we can write like this. The formula in the first case is F is equal to m into v minus u by t. So this is the formula we have to apply when there is no discussion of displacement here. So displacement is not discussed here. And in this case you have to apply the formula F is equal to m into 2s by t square, because a is t square here, 2s by t square. And this is the formula you are applying when there is no discussion of final velocity. In the third case, if you observe, what is the formula you are going to use? F is equal to m into v square minus u square by 2 into s, when there is no discussion of time here. So this formula you have to select. So these three formulas, that is 1, 2 and 3, different formulas we have to use when the situations are going to be different. Got the point? Okay, the next topic of Newton's laws of motion is connecting bodies. Connecting bodies of different types. The first connecting body is, it is called as Atwood's machine. It is called as Atwood's machine here. So let us discuss about what is the meaning of this Atwood's machine. So here in this Atwood's machine, there is a pulley, there is a block, here there is another block. Let us imagine this is of mass m1 and this is of mass m2, and this is a frictionless pulley which is connected like this. Okay, so in this case what is going to happen, let us see. You have to find out what is an acceleration of the two blocks as well as the tension acting on the string because of these two blocks. So for that, here let us imagine the tension is T. Okay, so you have to take a free body diagram in this case. So what is a free body diagram for mass m1? So mass m1, if you observe, how many forces are acting on this mass m1? One is m1 into g is acting downwards and tension T is acting upwards here. So if you observe these two, this block is moving down, this is moving up. The reason for that is m2 is greater than m1. As m2 is dominating m1, this is coming down and that is moving up. And on these bodies, if you observe, the body of mass m1, resultant force is acting upwards. That means acceleration is also acting upwards. When two forces are acting on a body, then also it is moving upwards. That means T is dominating m1g. Okay, what is happening here? T dominates m1g. Then one is dominating the other, then the resultant force is going to be T minus m1g. Why is it so? I told you already one example. Here 6 newtons are acting, here 4 newtons are acting. If two forces are acting on a body, then the body moves towards a dominating force. Therefore, the resultant force will become 6 minus 4, that is 2 newtons. So in this case, what is going to happen? So resultant force is T minus m1g. So here, according to Newton's second law, you can write it as m1 into a, that is T minus m1 into g. This is equation number 1. Now let us consider the free body diagram for mass m2. So for this mass m2, what is a free body diagram? So I have taken a mass m2. m2g is acting downwards, tension is acting upwards, and here resultant force is acting downwards because the acceleration is acting downwards. In this case both are acting upwards. In this case both are acting downwards. So resultant force is acting downwards in this case. When two forces are acting, then also body is going down. That means in this case m2g dominates tension T. As this is dominating, then resultant force is dominating minus not dominating. That is equal to 2 newtons. So in this case we write Fr is equal to m2g minus tension T. This is m2a is equal to m2g minus tension T. Okay. So this is equation number 2. Okay. So I think you are feeling bored. So this is equation number 1. This is equation number 2. Now you will do 1 plus 2. This is going to be 1 plus 2. Then you write m1a plus m2a So LHS you are adding. Then what happens to the RHS here? This is T minus M1 into G plus M2G minus tension T. So TT gets cancelled here. A is equal to M1 plus M2, which is equal to M2 minus M1 into G here. So A is going to be M2 minus M1 by M1 plus M2 into G here. Okay. So in this way we got the formula for acceleration. We got the formula for acceleration of the system. Once you get a formula for acceleration of a system, then you can substitute either here or there. Let us take one small example also here. What is that example? Let us see. So, example, if M1 is equal to 2 kg, M2 is equal to 5 kg or some 6 kg you can take. So 6 kg and G is equal to 10. Then find A and T in this case. So how do you find out this acceleration and tension in this case? If this is a question here, it's very simple. One thing is you have to find out the first acceleration, M2 minus M1 by M1 plus M2. What is M2 here in this case? M2 is 6. 6 minus 2 by 6 plus 2 into G, that is 10. Therefore it is going to be 4 by 8. Okay, so 4 by 8 into 10, that is 4 ones, 4 twos. Answer is 5 meter per second square. So we got an acceleration here. Once you get an acceleration here in this case, then you can substitute here or here, you can get tension here. It's very simple to find out the tension. So for example, you take this case, T is equal to, T left side if you take M2G minus M2A. So therefore T is equal to M2 into G minus A. Therefore what is M2? M2 is given here as 6 kg. So get 6. And G is how much? G, let us take 10 minus A is 5 meter per second square in this case. So we're getting tension as 6 into 5, that is 30 newtons. So this is the answer. So in this way you can find out the solution. Or else one more simple formula is also there. Substituting acceleration A in 1 or 2. Either in first equation or in the second equation, if you substitute, then you will get tension is equal to 2 M1 M2 by M1 plus M2 into G. This is also one shortcut formula we can apply here after getting the derivation of these two. Then we're getting T is equal to 2, M1 is 2, M2 is 6 by M1 plus M2 is 6 plus 2 into G is 10 here. So T is equal to 4, 6 is 24. And this is 6 plus 2 is 8 into 10. This is 8, 3 is 24. Therefore getting 30 newtons like this also. So this is a shortcut formula you can take here. So this is about the Atwood's machine. That is the concept of lift. Okay. So I'm considering a lift here. Now, this is a lift. In this lift, there is a weighing machine. You are standing on the lift now. Okay. So there is a weighing machine inside the lift. So this is a lift here now. This is a string of a lift. Now, let us consider the first case here. The first case is lift at rest. The first case is lift at rest. When the lift is at rest, how many forces are acting on you? First force is normal reaction and the second force is mg acting downwards. So normal reaction is acting upwards, mg is acting downwards. Now, for example, mass of the man is 60 kg and g if you consider as 10 meter per second square. So when the lift is at rest, normal reaction and mg both are going to be same. What do you mean by normal reaction? It's nothing but, for example, you have kept any body in your hand. How many forces are acting on this body? One is normal reaction, another is weight of the body. Weight of the body is always acting downwards. It is called as action. Opposite to that, perpendicular to the surface of the body there is one force acting. Normal means 90 degrees, a reaction means for the weight which is action, there is a reaction force acting upwards. Okay, that is called as normal reaction. So now here, if you consider the lift is at rest, lift is not at all moving, then you can write the formula N equal to mg. Okay, so what is your weight now? How much weight the lift is showing? Lift is showing 60 into 10, that is 600 newtons, or it can be taken as 60 kg weight. Okay, so your weight, if it is 60 kg, in terms of newtons, if you want to write, then you have to multiply with 10. If g is taken as 10, then your weight is 60 kg weight, or it is 600 newtons. Okay, so this is when the lift is at rest. Next, if you observe case 2, okay, so in this case 2, if the lift is moving up with an acceleration a, if the lift is moving up with an acceleration a, then what happens? What happens? Let us see. So let us imagine this is a lift in which there is a weighing box, that is weighing machine. You are standing in the lift, and this is the string of a lift. The lift is moving upwards, then resultant force also moves upwards. What is acting downwards? Mg is acting downwards. Normal reaction is acting upwards here. So let me give one basic concept here. For example, there is one block here. 6 newtons applied right side, 4 newtons applied left side. Then the block goes right side with a resultant force of 6 minus 4, that is 2 newtons. Okay, so resultant force will be towards the dominating force. Resultant force will be towards the dominating force, and acceleration is also towards the dominating force. This is the point we have to remember here. Then let us see what is going to happen in this case. So when the lift is moving up with an acceleration, let us consider the acceleration is 2 meters per second square. Let us see what is going to happen here. So now, if this is the concept, here two forces are acting on the board, on the person now. One is normal reaction, another is weight is acting downwards. If both the forces are acting, then also the body is moving upwards. The meaning here is resultant force is acting upwards. So N is dominating mg. Normal reaction is dominating mg. Therefore, we can write the resultant force as N minus mg. According to Newton's second law, you can write Fr is equal to m into a. Therefore, N minus mg. Therefore, we can write mg minus ma. N is equal to m into g minus a. Just now I told you that a body is moving upward with an acceleration of 2 meters per second square. You can write this as 60, and this is 10 minus 2. Therefore, N is equal to 60 into 8. Okay. Okay. So this mg, so here n plus mg, Fr is equal to n minus mg, ma is equal to n plus mg here. So if this is n, so n if you take, mg is transferred to the right side now. Okay, so ma n minus mg, so n is equal to mg plus ma, therefore n equal to m into g plus a. Therefore here we get plus here. Therefore 60 into 12, that is n equal to 720 newtons, or it can also be written as 72 kg weight. So you can also write this as 72 kg weight. Okay, so what is this called as? What is this normal reaction called now? It is called as apparent weight. It is called as apparent weight. Now apparent weight of a person is 60 kg weight. What is the meaning of apparent weight? Apparent weight is nothing but it is not a real weight. It is a weight which is imagined to be when the lift is moving upwards. It doesn't mean that suddenly your weight has increased to 12 kgs. You need not bother about obesity. Okay. So now let us see here. The next case, that is called as case 3. So in this case 3, if the lift is moving down with an acceleration a. Okay, when the lift is moving down with an acceleration a, what happens? Let us see here. So here, this is a lift. The person is in a lift. So this is a string. Lift is going down with an acceleration of 2 meters per second square, let us imagine. And therefore resultant force is also acting downwards. mg is acting downwards. Normal reaction is acting upwards. So now lift is moving down with an acceleration a. And it is experienced that when the lift is moving downwards, we feel a little bit less weight. We feel weightless a little bit. When the lift is moving upward, you feel as if you have been pressed down. You have been pressed towards the ground. That's why your apparent weight is going to increase, that is 72 kg weight. Now let us see what is going to happen in this case. So in this case, you'll write the resultant force is going to be mg minus n, and what is resultant force? It is ma, which is equal to mg minus n. So n, if you consider, you'll be getting mg minus ma. This implies that n is equal to m into g minus a. So this is the apparent weight when the lift is moving down. And what is its value? It is 60 into 10 minus 2, that is equal to 48 newtons, 480 newtons, or it can be 48 kg weight. Okay, so 48 kg weight. So a person who is at 60 kgs, when the lift moves down with an acceleration of 2 meters per second square, you feel that you are going to have a weight of only 48 kg. Okay, it doesn't mean that your weight has been reduced to 12 kg suddenly. It's not so. Okay, you will not feel happy that I have done a lot of exercise and decreased my weight like that. So it's not so, it is apparent weight. So lift is cheating us now. Lift is showing the wrong weight because of its own acceleration. Next, finally, let us consider case 4. In this case 4, if lift is moving up or down with an acceleration a is equal to 0, that means v is going to be constant. Moving up or down with an acceleration a is equal to 0, and it can also be called as uniform velocity. If the lift is moving with uniform velocity, what does happen? What does happen here? If the lift is moving with uniform velocity, velocity is going to be constant and acceleration is going to be 0. Then if this is the case here, what is the normal reaction acting upwards? So n up is nothing but m into g plus a. Here a is going to be 0, n up is equal to m into g, which is equal to 60 kg weight. Okay, so next case, n down. Here also m into g minus a, because when the lift is going downwards, m into g minus a will take, and here n down is m into 10 minus a. A is going to be 0 here, that is, this is going to be 60. Therefore, you're getting 600 newtons or 60 kg weight. Here also the same thing, you'll be getting either 600 newtons or it can be 60 kg weight. Okay, so what does it mean actually? The meaning of this is, when the lift is moving up or down with a uniform velocity with an acceleration equal to 0, your weight is not going to change. It shows an actual weight. Got the point? Okay, to understand this, I can give a beautiful example here. For example, you have been sitting in a train and the train is accelerating, slowly its speed is accelerating, and you have purchased some batanis in the train. You started throwing in your mouth. When the train is moving with uniform velocity, they will exactly go inside your mouth because there is no acceleration in that. There is no acceleration in the train. Train is moving with a constant speed, then batani will exactly fall into your mouth because uniform velocity does not affect the resultant force on the batani here. But for example, if the train is accelerating very fastly, at that time if you eat batani, what is going to happen? The batani doesn't go to your mouth, it may go to some other's mouth. Okay, so try to understand this one. So resultant force is not affected when the velocity is going to be constant. Apparent weight is not present. Your weight will be your actual weight. That is the meaning here. Okay, so now, okay, today we are discussing a small problem here and a shortcut solution for this problem. So how are you going to solve this problem here? So he is asking us to find out the force of interaction between the blocks. For example, in this block, the force of interaction is F1. In this block, the force of interaction is F2. In these blocks, the force of interaction is F3. And he is asking us to find out the forces of interaction in between these three blocks. How are you going to find out the interaction between these three blocks? First thing is you need to find out acceleration. Acceleration is nothing but the net force applied here by the mass net. Okay. So acceleration is net force by net mass. So how are you going to find out acceleration here? A is equal to F. Net force is F here. And what is a net mass? Net mass is m1 plus m2 plus m3 plus m4. Okay. So acceleration is nothing but F by m. From Newton's second law, that is F is equal to m into a. So now acceleration is equal to F by sum of the masses. He is asking us to find out force F1. So force F1 is nothing but m1 into a. Okay. So as force is F1 here, only it is acting on m1. Okay. So m1 into a. So if you want to find out force F2, what are you going to do now? So if you want to find out what is the force on m2, so force on m2 is nothing but F2 acting on that. So how are you going to find out this one? This is nothing but you have to add the two masses, that is m1 plus m2 into a. Okay. So m1 plus m2 into a, that is called as force F2. If you want to find out the force F3 here, it is very simple. F3 is equal to, as here there are three masses after F3. This is F3. After F3 there are three masses. So we are getting here M3, M1 plus, M2 plus, M3 into A. Okay. So this is a simple shortcut formulas for solving the problems here. So this is equation number 1, this is equation number 2, and this is equation number 3. Okay. So let us see the next problem here. So in this problem, there are three blocks connected. I mean, four blocks are connected here, and the force acting is upwards. So for example here, when the block is moving upward, any block is moving upward, a force is acting upwards, and mg is acting downwards. So as this force is acting upwards, therefore the net force is going to become the resultant force, which is equal to F minus mg. So here resultant force according to Newton's second law can be considered as m into a, which is equal to F minus mg. Okay. So here this resultant force acting here can be considered as F is equal to m into g plus a. Though this is you have to remember here. This is a basic concept which you have to remember here. Here the force acting on this place, if it is only one block present, you have to write this formula F is equal to m into g plus a. Then he is asking us to find out the tensions in these four masses. How are you going to find out the tension in the four masses? For example, if you take a free body diagram of mass m1 here, what is acting upwards? Tension is acting upwards, m1g is acting downwards. Okay. So resultant force is acting upwards. So in this case, how are you going to find out the tension here? So previously I have taken force, but here tension is acting here. So this tension is considered as tension T1. So you can just use this formula and make it a shortcut to find out the tension T1. So tension T1 can be considered as m1 into g plus a. It's very simple here. m1 into g plus a. This is a shortcut formula for finding the tension T1. Then what is the shortcut formula for finding tension T2 here? So to find out tension T2, it is very simple that you have to write m1 plus m2. Below this, how many masses are there? m1 plus m2 into g plus a. So this is a shortcut formula for finding tension T2. Then how will you find out tension T3 here? So tension T3 can be found by adding these three masses m1 plus m2 plus m3 into g plus a. It's a very simple shortcut here. So you can find out what is the net force acting on the upper block. The net force is just like here. It is nothing but m1 plus m2 plus m3 plus m4 into g plus a. So this is the formula we are going to apply here. So with this formula, you can find out what are the tensions acting here. This is a simple shortcut solution.
for multiple block and string concepts here. Okay, so now let us discuss the next problem here. There are 4 masses M1, M2, M3 and M4. In this question it is asked that find the force of interaction between the blocks. Previously we discussed horizontal case. It is a case where there is a inclined plane. So in this inclined plane, what are you going to do? What are the forces acting here? Let us see. So here the resultant force acting here is mg sin theta, whereas the force which is acting in this direction, this is a basic concept. This is a basic concept to understand this problem here. So basics here, if you are applying certain force that is called as resultant force, what is going to happen here? If it is only one block here, the resultant force is going to be the difference of these two, that is capital F minus mg sin theta. So this can be considered m into a, which is capital F into mg sin theta. So a can be written as F minus mg sin theta by m. Okay. So on this basis we can do any problem now. We can solve any problem. Now let us see here. For example, you have to find out the forces between M1 and M2. What are the contact forces? These forces are called as contact forces. How to find out the contact force between M1 here? So if you consider the contact force between M1, if you observe this as an M1, so F1 is acting right sides. This is acceleration A. In this direction, mg sin theta is acting downwards, it is mg, and in this direction mg cos theta is acting here. So in this direction mg cos theta is acting. So how are you going to find out acceleration here? Acceleration is already present, but you need to find out what is the force here. How can you find out the force? So same as the basic concept here, ma is equal to F minus mg sin theta, but here F is nothing but F1 here. So F1 can be found like this. This is ma plus mg into sin theta. As there is only one force here, you can write this as m1 into a plus g sin theta. Hence this is going to be the shortcut for the remaining forces. Now you can find out F2, F3 also. So if you want to find out F2, what are you going to do now here? So F2 means you have to consider the forces after F2. So then this will be the basic concept for the remaining formulas here. So F2 is nothing but here m1 plus m2 into a plus g sin theta, and similarly you can find out F3 also basing on this concept only, that is going to be m1 plus m2 plus m3 into a plus g sin theta. So F3 is equal to m1 plus m2 plus m3 into a plus g sin theta. Okay. So these are the forces here, F1, F2, F3. It's a very simple concept here. Whatever the force you are considering, that force depends upon the mass which is after that. So F1 means you have to consider mass after that. That is only F1. M1 is the mass after that F1. So if you want to find out F2, you have to consider the force masses which are beside F2 here. That means M1, M2 are there. So just write M1, M2. That's it. So next, if you want to find out F3, you have to consider the masses beyond F3. So it's a very simple concept here. That is nothing but, in general, we can write force F is equal to masses beyond into a plus g sin theta. This is a simple basic concept, or this is a basic formula you can say. So these are the forces F1, F2 and F3 for this type of concept. Okay.